Okay, so let's talk about one of my favorite topics, redox, oxidation, reduction. Redox is simply an abbreviation for that. So what do we mean by this term, oxidation or and reduction, those terms? So basically, whenever you have a chemical reaction, in some cases, it would involve changes in what we call the oxidation states, and I'm going to explain what that is about later on. These states are represented by what we call oxidation numbers, which are essentially equal to the charge on a monoatomic ion. As you're going to see shortly, there are some rules actually for determining the oxidation numbers of different atoms in a molecule or ion. So for example, in the case of sodium, we know that sodium can lose one electron to form the sodium ion. So basically, for this sodium ion, the oxidation state is going to be +1, whereas before it was 0. All right, and that is true for any monatomic ion. The charge on the ion is equal to the oxidation number. All right, now let me get into some rules. In fact, let me get out of this and get into another slide here. I think this more accurately gives you all the rules that you're going to need for determining the oxidation numbers of an atom in any substance. Now, these rules you don't need to memorize, but what you'll find is that when you continually use these rules, they become basically second nature. So let me just go through each of these rules step by step and then go on from there. So the first rule is that elements that are not combined with anything have an oxidation number of 0. So any element by itself, not in combination with any other element, we assume that the oxidation number of those elements will be 0. So it doesn't matter if it's a metal, non-metal, metalloid. If it's by itself, its oxidation number is 0, as you can see from these examples right here. All right. The next rule has to do with monoatomic ions, which we just discussed. In the case of monatomic ions, the oxidation number is equal to the charge on the ion. All right. So for example, in the case of the lithium ion, the oxidation number is +1. In the case of the iron 3 ion, the oxidation number is +3. In the case of the oxide ion, the oxidation number is -2. All right. Okay. Now this rule has to deal with specifically oxygen. It says the oxidation number of oxygen is usually -2. However, in peroxides, such as hydrogen peroxide or the peroxide ion, -1. All right, so if it's not in a peroxide, then if oxygen is combined with something else, then it's usually -2. All right, so that's one rule that you need to remember specifically for oxygen. Then we get to hydrogens. Now, in the case of hydrogens, if it's combined with any other element, then its oxidation number is +1, excepting if it is combined with a metal in a binary compound. In other words, if you have hydrogen bonded to a metal, then the oxidation number of hydrogen in these compounds was going to be -1. Okay, the next rule has to do with certain groups. Group 1A metals are always +1 when they're combined with other elements. Group 2 metals are always +2 when they're combined with other elements. And fluorine is kind of unique because fluorine, if it's combined with anything, is always -1. All right? And then we have this rule: the sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge on the molecule or ion. So for example, let's say you're given this formula here. This is the formula for the bicarbonate ion. And you're asked, what are the oxidation numbers of all the atoms in this particular ion? Well, we know that oxygen, is always -2 excepting in peroxides. And this is not a peroxide. And we know that hydrogen is +1, right? We also know that the sum of the oxidation numbers in a molecule or ion is equal to the charge on the molecule or ion. So in this case, we know that the sum of the oxidation numbers of the 3 oxygens, so that's 3 times -2, plus 1 hydrogen, so that's +1, plus the oxidation number of the carbon is going to be -1. So therefore, to find the oxidation number of carbon, we need to solve for this equation. And we find that in this case, the carbon will have an oxidation number of +4. All right, so as you can see, utilizing different rules among the collection of rules that I just went through, you can determine the oxidation number of each element in any compound. Okay, now I'm going to stop here because I'm going to post another video which deals with balancing redox equations. All right, so until next time.